Hi dears, today we can see some key points of analyticity and Cauchy-Riemann equations on complex analysis. The first one is if limit exists, limit of the function exists if and only if a limit of the real part, that is ux comma y, and the limit of v of x comma y is also exists. So function f of z is equal to ux comma y plus this one. So if the limit of the function exists means the real and imaginary function whose limit is also exists. The second one, the limit of the function exists. If exists, then it is unique. So if the function has p and p dash are the two limit points, according to this one, we can say that p is equal to p dash. So for the limit of the function, always be unique. The third one, f z is equal to u plus iv is a continuous function. So continuous function means a function is said to be continuous if limit z tends to z naught, f of z is equal to f of z naught. This is the condition of continuous. So if the function is continuous, then you can say that the real and imaginary part is also continuous. Now the fourth one, all the polynomials, the exponential, sin z, cos z is also continuous in every finite region. The next result, a continuous function of a continuous function is continuous. That means composite function is continuous. Similarly, f and g are the continuous function means f plus g, that is also continuous. Then f minus g is also continuous. Then f into g is continuous. Then f divides g is also, f divides g with the g not equal to 0 is also continuous. Together with the composite function is also continuous. So in short, it is given here as a continuous function of the continuous function is also continuous. The sixth one, if the function is continuous, then it is bounded in that region. So continuous implies bounded in the closed region. In the closed regions, continuous implies bounded. Then here you can see the seventh one, every uniformly continuous function is a continuous function. Uniformly continuous function is a continuous function. So now we can see what is the difference between the continuous and uniformly continuous. So we have the definition for the continuity is for any epsilon greater than 0, there exists delta greater than 0, such that modulus f of z minus f of z naught is less than epsilon whenever modulus z minus z naught is less than delta. So here is also uniform continuous is also for any epsilon greater than 0, there exists delta greater than 0 such that etc. whenever mod z minus z naught less than delta. But the difference between the uniform and continuity is, in continuity, the delta is depends upon epsilon and the particular point z naught. But for uniform continuity, delta does not depend upon, or delta depends only on epsilon, but not depends upon the particular point z. If it's so, that we can say that uniform continuous. This is the major difference between delta depends upon epsilon and the particular point. For the uniform continuity, delta depends upon epsilon and not depend upon, that is independent of the point z naught. So here the seventh one, uniform continuous implies continuous function. So when we can say that continuous implies uniform continuous means it is in the closed region. If it's so, we can say that this is possible. That is the eighth one. So if z is continuous in the closed region, then we can say that it is uniformly continuous. Then the ninth one, differentiability implies continuity. So differentiability, you know that the function exists. Differentiability means f dash of z is equal to limit h tends to 0, f of z plus h minus f of z divided by h exists and finite. Okay. So differentiability here, differentiability implies continuity, but the reverse is not true. Then we can see 10th one, a function fz is analytic. So the condition for analytic means a function z is analytic means the derivative exists. A function whose derivative exists, that is f dash of z exists at all points. At all points of the region, then we can say the function is said to be analytic. derivative exists at all points. So here the 10th one is, if a function is analytic, if and only if it is differentiable. So analytic implies differentiable, right? But one thing, it is in the open region. So analytic implies differentiable. This is possible for the open region. Similarly, we see the before results, like differentiability implies continuity, and continuity implies bounded, or continuous implies bounded. Then here analytic implies differentiability. This is in the open region. And similarly, continuous implies bounded. There also we see in the closed region. And now we see uniform continuous implies continuous, and continuous implies uniform continuous, possible for the closed region. Now we can see the 11th one. A function is said to be entire function if it means the function is analytic in the whole complex plane. The function is analytic in the whole complex plane. In the whole complex plane, the function should be analytic. If it's so, we can say that that function is entire function. Then 12th one, a function fails to be, if a function fails to be analytic, but in the every neighborhood of Z0, at least one point is analytic, then we can say that point is said to be the singular point. So if this is a region and the point is Z0, the function should be fails in this point. The function fails in the analytic, but in the neighborhood of that point, at least one point Fz should be analytic. If it's so, we can say that that particular point is said to be, this particular point is said to be the singular point. So two conditions, fails to be analytic, the neighborhood of Z0, at least one point is analytic. Then CR equation, we knew the CR equation, U and V satisfy CR equation means Ux is equal to Vy and Uy is equal to minus Vx. And if a function to be analytic, the necessary condition is this one, that is CR equation. So a function to be analytic, the necessary condition is it should satisfy the CR equation, and a sufficient condition for the function to be analytic is the first order partial derivatives, this one. Each and every one should be continuous. So the first order partial derivatives are continuous, then we can say that it is the sufficient condition for the function to be analytic. The next one, 14th one. Just before we seen the CR equation, that is for the Cartesian form, XY form. Now we are going to see that is a polar form. That is dou u by dou r equal to 1 by r into dou v by dou theta, and dou u by dou theta is equal to minus r into dou v by dou r. Polar form of CR equation. Then 15th one, if Fz is analytic function and u is the real part which is harmonic function. Harmonic function means it, here u is harmonic means the condition is uxx plus uyy equal to 0, or that u dou square u by dou x square plus dou square u by dou y square is equal to 0. So here function is analytic, u is harmonic, then we have this result, that is dou square u by dou u dou z bar equal to 0. This is mixed derivative, mixed partial derivatives. This set as mixed partial derivatives. Derivative is equal to 0. Then the 16th one, the function g is said to be the harmonic conjugate. When we will say that harmonic conjugate? So here the function g is the harmonic conjugate of h means the first condition is g and h are harmonic. And the second condition, first order partial derivative satisfies the CR equation. So harmonic, we know that the first condition, harmonic is g and h are harmonic means gxx plus gyy is equal to 0 and hxx plus hyy is equal to 0. The second condition, first order partial derivatives of CR equation, satisfy CR equation means gx is equal to hy and gy is equal to minus hx. If these two conditions satisfy, then we can say that g and h are harmonic conjugate of each other. Now we can see the 17th one. Two real valued function u and v are harmonic conjugate of each other, then the result if and only if they are constants. If and only if they are constant. So U and V are harmonic conjugates of each other, means if and only if, then we can say that U and V are constants. Then 18th one, if f is at if f is analytic function. If f is analytic, then the family of curves u is equal to constant and v is equal to constant. So orthogonal to each other. So orthogonal to each other, the condition is ux vx plus uy vy is equal to 0. So a function is analytic, means then the family of curves u equal to c1, that is constant, and v equal to c2 are orthogonal to each other. That is, it satisfies this condition. U and v satisfies this condition. Then we can see the 19th one. The harmonic conjugate of the function is unique. Right? The harmonic conjugate is unique. This is possible only up to an additive real constant. So remember, the harmonic conjugate is unique. And the next video we can see that how to use that Milne-Thomson method. Milne-Thomson method for finding the function to be analytic. Thank you.